Thank you very much for the opportunity to address this symposium. My name is Michael Kremer. I'm a professor at the University of Chicago. Today I'm going to discuss the international evidence on the health impacts of water treatment and principles for effective design of safe water policy. I'm also happy that my colleagues from Development Innovation Lab and UC Berkeley are able to participate in the discussions today. I recently released a study that found that treating water to make it safe to drink reduces the odds of under 5 mortality by a quarter. This suggests that water treatment is one of the most cost-effective ways to reduce child mortality. I'll speak a bit more about this study later in my talk, but I wanted to mention it now to highlight why I'm so enthusiastic about the Jeevan mission's incredible progress on improving access to safe water. I had the honor of meeting with Secretary Mahajan, Director Sheel, Director Singh, and many other JJM officials in 2023. Since then, I visited India twice more and met with JJM officials. So I've been able to observe the impressive progress on water treatment as JJM has piloted inline chlorination with technical assistance from Evidence Action and had very positive results. I'd like to recognize JJM's leadership in releasing the National Advisory to states in October 2023 and establishing this symposium to take the advisory to action. I'd also like to acknowledge and applaud the incredible efforts by Secretary Vinny Mahajan, Director Vikas Sheel, Director Chandra Bhushan Kumar, Director Y.K. Singh, Director Pradeep Singh, and many other JJM officials, as well as leadership in Andhra Pradesh, Madhya Pradesh, and Rajasthan. I'd also like to thank Principal Secretary Sushil Kumar Lohane and the team at the Department of Panchayati Raj and Drinking Water for the support and leadership for our study of inline chlorination in Odisha. The ORISA study is a research collaboration with the University of California, Berkeley, and ICMR Regional Medical Research Institute, Bhubaneswar. I'll now discuss the evidence on the impact of water treatment on child mortality. After discussing what we know about the health impacts of water treatment, I'll focus on one water treatment in particular, chlorination. Finally, I'll discuss some insights from economics that could be relevant for designing effective chlorination programs. I started working on water treatment in the early 2000s. I worked on a project testing the effect of protecting springs with concrete. This reduced contamination at the water source by 2/3. However, when we tested household drinking water, contamination had only fallen by 1/3. This is because water can become recontaminated during transport or storage. Preventing contamination at the source didn't prevent this. This is why I shifted my focus to water treatment. There's strong evidence that water treatment reduces childhood diarrhea. There have been many randomized controlled trials demonstrating this and a nice meta-analysis. However, there's been less evidence on the link between water treatment and child survival because child mortality is a rare outcome, requiring a very large sample size to analyze. Most studies are smaller, designed to measure childhood diarrhea, which is a much more common outcome. To address these, my colleagues and I conducted a meta-analysis. That was with a team of co-authors, including Stanford epidemiologist Steve Luby, biostatistician Witold Vicek, and economist Brandon Tan and Ricardo Martins. We identified all of our available randomized controlled trials of water treatment, which met our inclusion criteria, and checked whether they had mortality data. If mortality data wasn't published, we contacted the authors to see if they had this information. We identified 18 experimental studies of water treatment meeting our inclusion criteria. The forest plot you can see here shows our results. Each circle represents one of the studies. The size of the circles represents their weight in the meta-analysis. Studies with more deaths, generally those with larger samples and longer follow-up periods, have more weight in the analysis. The vertical line would indicate no effect. Points to the left represent reductions in the odds of mortality. The horizontal lines are 95% confidence intervals. They show the uncertainty in the estimated effect in each study. The individual studies, you'll see, are small, and so they have wide confidence intervals. But the overall effect of it is a 25% reduction in odds of under 5 mortality. That's when you combine all of these studies. And that's very statistically significant. And then if we restrict this to the studies of chlorination only, you see very similar effects. So I'd like to highlight first that this is truly a very, very large effect with potentially 1 out of every 4 child deaths in low and middle income countries that could be prevented by treating water. So I think that's very important for policy, and I'm very excited to see the attention that India and JJM are devoting to water. So far I've talked about water treatment technologies in general, but now I'd like to focus on one particular technology, chlorination, and within that, inline chlorination. So there are a few reasons for that. First, chlorination is safe and highly effective. It's been used to treat water for more than 100 years. It's still the primary means of water treatment in high-income countries, including the United States, where I live. Other technologies like filtration and UV treatment can make water safe, but they don't keep water safe during transport and storage. If water comes into contact with contaminants again, it will be recontaminated, as we found in one of the very first studies I was involved in on water. In systems that don't have constant pressurized water supply, negative pressure in pipes pulls in material from outside, causing recontamination. Similarly, in settings where water is collected once or twice daily and stored in open or semi-open spaces, or in containers handled by many people, it's prone to recontamination. Now, if water is treated with chlorine, then residual chlorine in the water keeps it safe for much longer, preventing recontamination as long as residual chlorine is present. For this reason, the World Health Organization recommends that water treatment is dosed to maintain a residual concentration in the water to provide some protection from post-treatment contamination during storage. Now, in many countries, including Brazil, UK, much of the US, it's a regulatory requirement for water companies to have a certain level of residual chlorine in their water so that it remains safe. Inline chlorination is one promising delivery system for chlorine. It can dose chlorine automatically and precisely in piped water systems without electricity at a very low setup cost and a low running cost of a few hundred rupees per person per year. We looked at the cost effectiveness of water treatment by combining the meta-analysis result with estimates of the cost of various delivery systems for water treatment, including inline chlorination. And what we found is that water treatment with chlorine is one of the most cost-effective health interventions, comparable to childhood vaccination. For a given budget, almost no other child health policy will prevent as many child deaths as water treatment. So the fact that JJM emphasizes provision of water with water treatment through explicit water quality monitoring standards and guidelines is important for saving lives. And in fact, we can quantify this. Combining evidence from the meta-analysis with data in India, my team and I estimate that if JJM provides safe, treated water to all households in rural India, it would avert 1.36 lakh child deaths every year. That's, by the way, in line with similar estimates calculated with a different methodology by the World Health Organization. If any of you would be interested in state-level estimates, we'd be happy to calculate those as well.